Keeping your home comfortable throughout the year is an important aspect of any well-designed home. In this multi-part series, I'm designing the ultimate smart home from the ground up. And today, I'll talk about HVAC systems. My name is Steve, and this is it-alchemy. Heating, ventilation, and cooling, better known as HVAC systems, are crucial when designing any home, especially the ultimate smart home. HVAC systems are one of the largest energy consumers, and our goal is to be energy independent as possible, so we need a very efficient system. In Alaska, we deal with summers that average 70 to 80 degrees Fahrenheit, with extremes pushing even to 100 degrees. In the winter, temperatures average between 0 and minus 20 degrees Fahrenheit. I've even experienced minus 70, which is pretty miserable. So for our heating system, it all comes down to energy efficiency, which we can achieve in several ways. A great place to start is having a well-insulated, tightly sealed building envelope, like the smart wall system we talked about in another video. If you missed it, check it out in the structure video here. So how do we actually create heating and cooling? Most homes in my area used forced air furnaces or boilers with hydronic flooring, running on heating oil, propane, or natural gas. Some homes even use electric baseboard heaters or even have wood or pellet stoves and kerosene heaters. But we don't want to mess with any of that, because the problem with all of these systems is they're not very efficient. Fuel is expensive, and having it delivered is even worse. Plus, if you want to haul it yourself in freezing conditions, it's a huge hassle. So what's the solution? Geothermal. Geothermal systems use a device called a heat pump to move heat from one place to another. There's pretty much only three types. There's air, water, and ground source. Air and water source systems have some trouble in Alaska's cold winters as their efficiency drops dramatically in these sub-zero temperatures. But at a certain depth, the ground temperature stays a steady 50 to 60 degrees Fahrenheit no matter how cold it gets on the surface. That's why a ground source geothermal system is the best solution for this home. The heat pump has several components, with the first being the ground loop. This can be either run horizontally or vertically down into the earth. The length of the loop depends on the tonnage or capacity of the system. Vertical loops by nature are shorter, but they require drilling, which can be pretty costly. Horizontal loops, on the other hand, are quite a bit longer and they require more space, but luckily our property has the space needed for these horizontal loops. Something interesting about heat pumps is that they don't burn fuel. They run off of electricity, but very little compared to other systems. They work based on a simple principle. Heat always wants to transfer to a colder medium. Free science, guys. Second law of thermodynamics. Inside the loop is a water antifreeze mixture, and this liquid moves through the ground loop. When it gets to the ground, it absorbs heat from the earth, which then travels back to the heat pump. Inside the heat pump, the liquid passes through a refrigerant with a really low evaporation point, which absorbs the heat and turns it into a gas. The gas then goes into a compressor and is compressed, which raises its temperature, and then it transfers that to heat the air or the water in the home. This process can also be reversed to cool the home. Heat pumps are rated by their coefficient of performance, or COP. A COP of 4 means that for every 1 kilowatt of electricity, 4 kilowatts of heating or cooling is produced. That's smart energy use. Now, I'm not really a fan of forced air systems. They're loud and they can stir up dust, and the heat dissipates really quickly. I would much prefer a hydronic floor heating system. Hydronic systems pump hot water into tubes that are embedded underneath the floor, and that heat radiates upwards to warm the room. This type of heating mimics the body's natural heat curve, and it's by far the most comfortable way to heat a home. These can be installed in the floor or the walls or even the ceiling. It does take a bit longer for it to heat the home, but once it's at temperature, it stays there with minimal effort. Plus, it provides a much more even distribution of warmth than forced air systems. For the geothermal system, I'd go with a Waterfurnace 5 series that's perfect for a water-to-water application. It can handle heating the hydronic floors and produce domestic hot water. However, I'd still probably want to include an electric backup heater for those worst case scenarios when the geothermal system might underperform. Luckily, there's electric heater add-ons available. Water furnace systems can also be zoned, which is great for areas of the home that need different temperatures, like upstairs rooms or basements. Plus, we can even add hydronic underlayment to the driveway and melt the ice and snow. Because we're not using forced air and this house is so tightly sealed, indoor air quality is a concern. We can't just open the windows when it's freezing outside, so how do we bring in fresh air? The answer to that is pretty simple: an energy recovery ventilator, or ERV. An ERV pulls stale air from inside of the house and replaces it with fresh air from outside. It has a heat exchanger that helps transfer warmth from the outgoing air to the incoming air, reducing the energy required to heat or cool it. Most homes need about a 0.35 air exchanges per hour, which means roughly a third of the indoor air gets swapped out each hour. In the case with our home here, it's 3,300 square feet, so we'll need an ERV rated for at least 154 CFM. For this, I like Renew Air ERVs, which have models that provide the necessary CFM and help keep the indoor air quality in check. So now the ultimate smart home has a heating and cooling system and is both efficient and comfortable. The air quality will be excellent and we can maintain comfort all year long, even in the harshest conditions. If I missed anything or you have suggestions for improving the HVAC system, drop a comment. Also, don't forget to like, subscribe, and follow along. In the next video, we'll talk about water systems. Thanks for watching.